Welcome to the sixth lecture. We are studying stochastic processes and we are studying Poisson process. So we will continue studying Poisson process even in this lecture. Today we will solve an example where it's the same example that we have been talking about in last few lectures. There are fluctuations at my residence. There are 3 per minute in my input AC voltage. Given this information and given that it follows a Poisson distribution, we want to find out the probability of 5 fluctuations in 2 minutes and then 10 fluctuations in next 5 minutes. So actually what we want to find is this probability of 5 fluctuations in 2 minutes jointly with 5 fluctuations in next 5 minutes. So we have 2 intervals. The first interval is of 2 minutes duration and the next interval is of 5 minutes duration, whereas lambda is the same here and here. Lambda is the same here, the same here. Lambda is the parameter that remains the same. So what we need to find out that what is the joint probability of having 5 fluctuations in this span and 10 fluctuations in this span. Since Poisson distribution, the Poisson process does not show any dependence, any intervals that are non-overlapping. We have already studied that any non-overlapping intervals are independent of each other. So the probability of having 5 fluctuations in this span is independent of having the probability of having 10 fluctuations in this span is independent of having 5 fluctuations in this span. So this joint probability term can be written as this time x equals 10 to t equals 5. So this joint probability term can be written in terms of these marginal probabilities. So probability of 5 fluctuations in 10 minutes follows Poisson distribution minus lambda e to the minus lambda t. Lambda is 3 times t is 2, lambda t to the k is 5 here over 5 factorial. For this is e to the minus 3, e to the minus lambda t 5, 3 to the 5 times k, which is 10 over 10 factorial. So in part B of this example, in part B, we have to find out probability of, we need to find out in part B, we need to find out probability of 2 fluctuations in 2 minutes given no fluctuation in last 10 minutes. So mathematically we can write it as probability of x is equal to 2 fluctuations in 2 minutes given there is no fluctuation in last 10 minutes. We know that whatever is going to happen in this span of 2 minutes is independent of what has happened before. Therefore, probability of A given B is probability of A, means probability of x equals to t is equal to 2, which is e to the minus lambda 3 times 2 to the k over k factorial, which is 2. In part C, there is a part C for this example where we have to find out average number of fluctuations in 10 minutes duration. This is the average value, and we know that the expected value of x for a Poisson process is lambda times t. So this is actually the mean value, the average value. Lambda is 3 multiplied by 10 minutes is 30 fluctuations. So expected fluctuations are 30. Expected fluctuations are 30 in a span of 10 minutes for this Poisson process. And the last part of this example is we need to find out variance in fluctuations in 5 minutes duration. For this Poisson process, we know that for Poisson process, the variance of x is the same as its mean value, lambda times t. So variance is the same as the mean 3 times 5. So the variance for this span is 15. In our upcoming lectures, we will keep on studying more about Poisson processes. Thank you.